Hello guys, and welcome to another video. On this one we're doing question 5 of June 2024, grade 12. 5.1 says a wrecking ball is used to demolish an old building by smashing into it. The wrecking ball has a mass of 950 kg and is suspended in the air with a second rope 3.5 meters above the ground. The ball is then released to smash into the building. At the lowest point of swing, the ball is at a height of 1 meters above the ground. And then they say ignore air friction. Okay. And then when we proceed, the first question we have is to state the law of conservation of mechanical energy. This is grade 10 work, guys. The way in which we state the law of conservation of mechanical energy is to say, in an isolated system, the total mechanical energy is conserved or remains the same. In an isolated system, the total mechanical energy is conserved or remains the same. That's how you state it. You can say it's constant or it remains the same. All right. Now we move on to 5.1.2. 5.1.2 says the ball swings and hits the building at height h. Calculate the speed at which the ball hits the building using only energy principles. You'll realize that the way it's using energy principles comes from the topic of work energy theorem, right? Or rather, work energy and power. My bad, work energy and power. But based on the fact that they asked us to state the law of conservation of mechanical energy, the formula that I'm going to prefer to use is one of the law of conservation of mechanical energy. But you can use other useful formulas from the work energy and power topic. However, in this case, this is the one that I'm going to use. And with this one, I'm going to say MGH. We know that mechanical energy before and mechanical energy, by the way, is the sum of what the potential and kinetic energy. So the mechanical energy before has to be equal to the mechanical energy after. That's what we will be using here. So this one is initial velocity and this one is going to be final velocity. This is after final. And then we'll substitute. And when we read our statement, guys, you'll realize that the ball was, okay, let's start with the height. We have to substitute on MGH. So M is gonna be the mass of the wrecking ball, which is what? It's 950 kg. And then the G is constant, it's 9.8. What about H? H is the height, right? It's the height at which the ball was initially, and the ball was 3.5 meters above the ground. So this is the initial height. It was 3.5 meters high. So I'm going to put 3.5 here. Plus, in terms of the velocity, the initial velocity, where was the ball initially? The ball was at rest. The ball had not moved, right? Before it was suspended, it had not moved. It was still at rest. So it means that we didn't have the initial kinetic energy. My advice is that you substitute here, guys. I'm not going to substitute now, but you would have to substitute here, but the answer would be 0 there. Okay, the answer would be 0 because the initial velocity will be 0. Then when we go next door, we know that the mass is still the same. It's 950. The G is also 9.8, but the height has changed. Initially, the height was 3.5 meters, but now it's 1 meter high. The ball is now suspended 1 meter above the ground. So the new height is 1 meter. And then we'll say half M. The M is still 950. What about VF? VF is actually what we are looking for. The question said we have to find what? The speed, which is that VF. So that's what we are looking for. And then from here we do the math. Multiply this. I don't know what the values are. Let me just calculate. I don't have a calculator as I'm using my phone. So yeah, let me just quickly pause and calculate. Alright guys, so when I multiply these ones, the answer I'm getting is 32585, and this side when I multiply, the answer I get is 99,310, plus here I'm gonna get 475 VF squared, and then I'll transpose this one to the other side, so I'll have 32585 minus 9310 is equal to 475 VF squared, and then I'll divide by 475 on both sides. 475 on both sides. These are going to cancel, therefore my VF, which is the speed, will be equal to this one I'm gonna get from the calculator, and my calculator is gonna give me an answer of 7 meters per second. So this is our speed. Remember, speed is a scalar, so we don't need the direction for it. Hope it makes sense. Okay, now we move on to the next question. The next question, guys, says the ball hits the wall, it takes 0.1 seconds to stop and then rebounds. Calculate the magnitude of the force with which the ball hits the wall. And once you see the time and then you see force, you must think what? Impulse, guys. The impulse formula as well. And we know that the impulse formula is F net delta t is equal to change in momentum, delta p, right? And we know that momentum is a vector. So when we deal with momentum, we have to remember that it's a vector, and even our velocities have to have direction due to that fact. And what we'll realize is that they say the ball will then rebound, but the question is saying what is the magnitude of the force with which the ball hits the wall. So when the ball is about to hit the wall, it's moving in one direction. It's moving in the positive direction. I hope, guys, that makes sense. So if it's moving in the positive direction, or rather in one direction, we'll take that direction as positive, and that direction is what? Towards the ball. Towards the ball is positive. Please excuse the noise that you are getting, guys. I'm at my workplace, and yeah, things are being done outside. So the direction towards the wall is going to be positive. And now when we expand on this formula, we are now substituting. Let me just remove this one here. So now we are going to substitute into that formula. It's F net delta t is equal to change in p. I'm going to expand here first. F net delta t is equal to m in brackets v. What are we going to have here? We are going to have... Okay, so our formula is going to be Vf minus Vi. So in order for us to substitute into this formula, we'll have F net, and then our delta t will be 0.1. That's the time that we're given. And then our mass of the ball will be 950. Then we move on to our velocity. For our velocities, guys, I think if we go to the statement, they are saying that the ball hits the wall, and then if the ball hits the wall, okay, it takes 0.1 seconds to stop. So after it has stopped, it's going to then rebound. So towards the wall, our direction is positive, and then it will rebound. So when it rebounds, it means that it's hitting the wall and then coming back, right? And if that's the case, we know that initially the ball was at 0. It hit the wall at a final velocity of 7. But what you'll realize that is that the direction will now change, right? When the ball rebounds. How is it changing? It's going to hit the wall and then go backwards. And if that's the case, the initial velocity will then change into 7. Why? Because it's going to move with that initial velocity from the wall, whereas it rebounds. And If that's the case, it means our initial velocity would have to be 7 and our final velocity will have to be 0. Okay, and that's how we are going to basically substitute on our formula. But in this case, direction is going to be important as well. So for our direction in this case, we can have a situation whereby, remember I said towards the wall we have to go positive, so away from the wall we have to go positive. I think that's how I'm going to take my direction, to say if it rebounds, it's now moving in the other direction, away from the wall. So away from the wall we would go with negative, so that means the initial velocity will be negative and our final velocity will be 0. Okay, so when I substitute here, my final velocity is going to be 0 and the initial velocity will be negative times negative 7, and this will obviously be a positive value, and then I'm just going to divide by 0,1 on both sides. And if I do that, I'm correct. If I divide by 0,1 on both sides, the answer I should get is 66,500 newtons. I hope, guys, it makes sense. Remember, towards the wall is positive, away from the wall is negative. So when it rebounds from the wall, it does so in the opposite direction, and that final velocity becomes the initial velocity for the ball to rebound from the wall. Hence, I'm using that 7 for the initial velocity, and the ball will obviously come to a stop. Thus, the final velocity will be 0. The last question says we have to write down the force that the wall exerts on the ball, and they say name and state the law in physics that is used to arrive at this conclusion. The force, guys, that the wall will exert on the ball is opposite of this one. So this is the force that the ball exerts on the ball. The ball will also exert that force, but where is it going to exert the force towards? It's going to exert it in the opposite direction. Obviously, the ball is coming from the left, the wall is on the right. This is from the diagram, right? The ball is on the left, the wall is on the right. So this means that the wall will exert its force in the opposite direction, which is the left direction. Towards what? Towards the ball. The ball exerts the force towards the wall in the right direction. The wall exerts the force towards the left direction. That's why even here on the rebound we say that the ball moves away, because the wall will exert the same equal force but in the opposite direction, away from the wall, which is in the left direction. So the force that the wall will exert on the ball is this one, but it's going to exert it in the left direction. I hope you understand that, guys. So that's what's going to happen in the left direction. And which law helps us to understand this? It's Newton's third law. Okay, it's Newton's third law, and it states that when an object, or rather when object A exerts a force on object B simultaneously exerts an oppositely directed force of equal magnitude, or you can say object B simultaneously exerts an opposite but equal amount of force on object A. That's how you answer this last one, 5.1.4. I hope, guys, you found this video to be helpful, and likewise please do give it a thumbs up, and yeah, see you on the next one.